Welcome back. It's finally some nice weather out at the old Cleveland Skunk Works here. So, switching gears, if you saw the last video, I put the magnetometer in. I've since pulled it back out. It's not going to stay on that shelf while the wings get bounced around. It'll live in a box safe up on the shelf somewhere for the time being. Cable's all in. Oat probe is run, so that's all good. I am starting on the left wingtip. I got to get some help to get it out of the cradle and onto a table so I can do what needs to be done to it. Until that happens, I have to find some other things to preoccupy my time, and it has dawned on me that I have not dealt with the push tubes that go through the wing for the ailerons. This starts out as a 12-foot piece of material. This one is the correct size diameter for the RV8. The one Vans originally sent me, which I still have up there, is for, I think, an RV10. It's much bigger. First step in dealing with these, though, is to cut them to size. That is 69 3/16 of an inch long from end to end, and then they get these threaded aluminum ends installed and riveted in 6 places around the circumference. So that's what I'm going to do today. I'm just going to get these drilled and built up so I can get them put into the wings and they can just live there and not up on the shelf anymore. It's one more thing to check off the list of things done. In the interest of making that, I stole a page from Chris's book since I have the Magic 3D printer, and I spent a very long time, I'm not even going to say how long, in Fusion 360 designing a drill guide so I can perfectly drill all 6 of these holes in the right depth that they need to be so that I have edge distance. Took a very long time. I learned a lot about Fusion 360, which was awesome. And then when I was ready to download it and save it, I also learned that my free trial of Fusion 360 is up, and I can't save it or download it or do anything with that fancy file I made. And can't bring myself to pay what they want every month for it since I don't use it that often. So I went to Tinkercad online, and it took me literally, 10 minutes to design this on Tinkercad. More than acceptable. And yeah, we're going to use it. The way it's going to work, I'll show you on the cut off piece, is stick that on the end of the tube, and now that will give me holes the perfect depth all the way around. So we'll do that. We'll get those all drilled and cut. I did already cut the pieces to the right length. As you can see, they are manageable sized. They are the proper length now. I did that using the good old pipe cutter. Best way to make sure you get a nice straight cut on round tubing. So that's it. This will probably be a very short video because that's probably all I'm going to get to, and we'll go from there. Okay, welcome to the voiceover part. So, tried a couple of different ways to do this. I wasn't sure about drilling through the drill guide itself. I thought about just using it to mark, which is what you saw me do there. That didn't work out, so I decided I would drill a singular hole through it, use a cleco to hold it, and then I would mark the rest of it and then drill it. And as I was marking it, I discovered my mistake, which some of you might have caught during the intro, because apparently I can't count. Yeah, I designed that drill guide with 8 holes in it instead of 6. Thankfully, I caught it before I drilled anything more than 1 hole. So, all right, mid-build update here. Some of you might have seen it in my intro when I was showing off the drill guide I made, or you saw it in the video, but I didn't catch it. Thankfully, I caught it in time. I didn't catch it when I built it. There are supposed to be 6 holes around this for 6 rivets that go into that push-pull tube, and the first one I made had 8 holes. I have no idea how I threw the extra set in there or screwed that up. I got it over onto the drill press. You might have seen me drill that first hole. Thankfully, as soon as I drilled it and I looked, I realized something was wrong, and I didn't drill any other holes. So we should be good. Ran back inside, redesigned it with 6 holes instead of 8, printed it. Took all of about maybe 30 minutes to complete. So we're back to try this again. Hopefully that was the last mistake. Okay. So there you can see the new one versus the old one. Throw that old one away so I'm not tempted to try and use it again, and press on with pride. Just like I described, go ahead and put it on there, cleco it in place. There you go. And drill around it. Worked out really well. Perfectly spaced holes, perfect edge distance, and good edge distance on the insert that has to go in there. So rinse and repeat. Do this for the other tube, and then I'm going to use the tubes themselves as drill guides to drill the inserts that go in there. Now, unlike the inserts that go in the smaller push-pull tubes from the bell crank, the steel ones, these are very sloppy. Those ones in the smaller ones are like a pressed fit. In fact, I had to put the insert in the freezer and heat up the tube a little bit to get it to go in there nicely. These are not that way. You can see just how easily I can stick that in there and pull it back out. So what that means is, you see me with the square, it has enough wiggle room and give that when you're drilling it, if you don't make sure that it stays straight, you could definitely make it crooked. Would it be the end of the world? No. There's a heim joint in the end of that thing. So that would make up any, slack, I guess, for that thing not being perfectly straight, since it would be able to pivot. But the straighter it is, the better it's going to be. The way I combated that was I drew a line around it once I got the first hole in there, pulled the thing out, made sure the line was concentric and straight. I used that kind of as a rough guide to know if I needed to push or pull the piece in or out on the opposite side. And then I just kept using that square every now and then, at least until I got about 3 of them in there, just to make sure it was staying as true as I can make it. And as best I could tell, it worked out. They seemed to be straight and true. The very end of this video, which is coming up shortly, I'm going to throw up pictures of it completed, as well as I got the edge guard material, the silicone edge guard material in, I mentioned in the previous video, for the lightning hole in the spar where the wires go through. So there'll be a picture of that and a second picture that kind of shows the 3D printed cable clip I made for the magnetometer. So if you were curious and wanted to see those, I went ahead and threw them in the end of this video. Anyhow, now they're all drilled, so back to the bench. I did mark them. I labeled them 1, 2, 3, and 4, the cap and the end piece, and I put the numbers lined up with the rivet holes. That way they lined perfectly back up, which I did figure out when I accidentally tried to put one of them in the wrong way. It did make a slight enough difference that things didn't line up perfectly. So if you're doing that, make sure you mark them. It'll help put it back together. Now you see me deburring the holes and putting in, I think they're MSP42 blind rivets. I believe they're stainless. I'm not 100% sure, but they're beefier blind rivets. And now you can see me fighting again with that rivet gun. It really just seems like the teeth in there don't have enough grip to grab hold of the stems each and every time. So sometimes it pulls and sometimes it doesn't. Finally, just like every other time, I get frustrated and give up and just go to the manual one. If I'm ever to build an airplane with pulled rivets, I will definitely be getting a pneumatic pull rivet gun for that. Do better, Milwaukee. So quickly coming up on the end, the last thing that you don't see me do that I did off camera was you have to measure from eyelet to eyelet when you install them. It's got to be 72 and 11/16 inches, I believe. So I just hung it on a nail on one of the wooden posts in the garage and measured 72 and 11/16 down from that. And while it was hanging vertically, I just threaded or unthreaded the rod until I got the perfect spacing, and then I ran the jam nuts down. So they're done. They are sitting on the shelf because they do stick out of the wing a fair distance, so I don't want to leave them in the wing, but they're done, out of the way. Hopefully it'll be on to the other wingtip here soon. As always, go check out the podcast if you haven't seen that yet. I'm sure we're probably due to record another one here soon. And if nothing else, leave your questions or comments down below, and I will see you all on the next one.